Hello everyone. Today we are going to discuss about the Microsoft AutoGen's Magentic One framework. So this is the GitHub repository which I have, which explains the workflow of Magentic One and its purpose. But before we jump into it, let's understand about Microsoft AutoGen framework. So Microsoft is actually providing two different frameworks for AI integration. One is with Semantic-Kernel and another one is the AutoGen framework. So Semantic-Kernel I have already explained in one of my repository. You can refer that. I have given the link here. Whereas AutoGen is serving a different purpose compared to Semantic-Kernel. So basically Semantic-Kernel has the Pythonic way of configuring different workflows like chat completion agents. With the help of this class, we can create agents by inputting the respective system message and the configuration that require for the agent to work. Whereas AutoGen is actually having a pre-built agents, and it is basically a jumpstart to semantic kernel. So semantic kernel has a selection strategy, termination strategy. We have to define everything by ourselves by configuring that in Pythonic or hash, C hash and .NET coding structure. Whereas AutoGen is also providing all these options, whereas it has the basic code ready to build agents without any hesitation like semantic kernel, where we need to start from scratch. Whereas in AutoGen we have few agents readily available, and if required we can customize our agents as well. So that is for enterprise integration, whereas AutoGen is actually for agentic capability. So inside AutoGen, if you see, we have a Magentic One framework, which is not completely a prototype. We can make use of it, but there are certain cautionary instructions that has been given by AutoGen, because it is taking control of the system on its own to perform the respective action which is given by the user. So all these things we will look into it. So if you go into the AutoGen documentation, here you can see that this tutorial is actually making use of AutoGen framework to build AI agents, and for our explanation that I'm going to give with respect to Magentic One, if you see, there are certain agents which are already available with respect to AutoGen, like assistant agent, user proxy agent, web surfer, coding agent, and so on. So if you see here, these are some of the agents which are already available. So as I said, the user proxy agent is like whenever we introduce AI agents, it is mandatory that a human in the loop should be present, so that whenever the agent is getting deviated from the actual task, we can actually control it through a provision called human in the loop. So to make it available, AutoGen is actually giving user proxy agent where it can get the input from user then and there, and then it can perform the operation whenever it is getting stuck. And as you can see, like, there is code executor agent where it will be executing the code in any language, and web surfer where it can actually get into the system and then browse with the help of internet, and then perform the operation that we require. And we have file surfer where it can explore your directories and then get the information that you require. And there are some other agents as well, and if you want to create different agents on your own, that is also possible. We can make use of the implementations available in AutoGen SDK, and then create the agents whatever is required. So coming back to Magentic One, to demonstrate the capabilities of Magentic One, in this repository I have created or used some of the components which is supporting the workflow. To showcase the same, I'm just going through this repository. So semantic kernel is also used in this, because AutoGen Magentic One framework is actually a task-oriented framework where open-ended tasks can be executed directly. So to make it available as a chat interaction with the user, I have used semantic kernel chat completion agent to interact with Magentic One. So whenever user is asking a generic question or a greeting, it will be taken care by the chat completion agent of Semantic-Kernel. So whenever the user is giving some workflow which is actionable item, then by making use of kernel functions in Semantic-Kernel, I'm invoking the Magentic One workflow. So that from there, the agents which are present inside Magentic One will be taking care of the activity. So to showcase that in UI, I'm using a Gradio chatbot, and in most of my repositories, you could see like I'm using only Azure related components. So here I'm using Azure GPT, OpenAI GPT 4.0 model, and some of its components. And when you come down here, so this is the architecture which is given by Microsoft in their documentation for Magentic One. So if you see here, there is an orchestrator which is already available, and it also has file server, web server, coder, and computer terminal agents present. So whenever a user is asking something, it will give the control to any one of the agents based on the nature of the problem statement, and then it will execute it. So if there is a failure in the execution, then again the response will be coming back to orchestrator, because it has a track of what is the request which has come from the user, and what is the process which is getting executed inside the system, and it is having a track, so that whenever there is a success or failure, it will be reassigning the plan or recreating another plan to complete the process. So orchestrator is actually controlling the workflow. So this is what Microsoft is giving us as the workflow. You can see more details in the documentation. So some of the components which are present here is explained in this repository as well. So multimodal web server, it is making use of Chromium browser, where the request, if it requests to access a website and fetch information, it can make use of that. Since these agents can do autonomous activities, if there are any cases where if some browsers, I mean some websites are asking for cookie permissions, then without user intervention, it is actually accepting or rejecting the agreements by itself. So we may need to monitor the logs, like if there are any workflow which is harmful is happening without human intervention. So we may need to monitor the logs appropriately. So that's why if you see the documentation, they always say that execute this Magentic One workflow in a sandbox, so that if at all any corruption or any vulnerabilities occur in the system, then we can actually decommission the sandbox itself instead of having the workflow in the system. So like that, we have file server agent where it will be navigating across the directories where the actual workflow is incorporated, and we have coder agent as well. So it will generate code and then try to execute. Similarly, like how it is accepting the cookie agreements, it will be executing the code by itself. All these things I will showcase to you when I execute the code, and we have the orchestrator as well. So when you see before getting into Magentic One, we have something called the Magentic One group chat. So all the standalone agents which I have explained here can be made use with the help of a Magentic One group chat agent as well. So we can just configure, in this case, if you see here, I'm just configuring a multimodal web server and then putting that as a agent inside a Magentic One group chat. So the difference between Magentic One group chat and Magentic One is that Magentic One is having all these web server, file server embedded, bundled inside it, whereas here we can actually customize our agents. So this is how it is defined, and important notes from Microsoft, like whatever I explained earlier, like we may need to run the Magentic One workflow in a container so that any autonomous activities which are very harmful to the system can be avoided. And you can see the points here. They have expanded some of the risky behaviors because of the vulnerabilities happening in the sites. If it is approaching the respective site, then it may be a problem to us. So it is always better to go with a sandbox. So coming to the execution, if you see, so this is the basic syntax that Gradio provides for the chatbot. and I have hard-coded the port where the service should get started. And this is the method which get invoked whenever user is giving some input. So if you see here, I'm just taking the user message and then add it to the chat history, which is the component of Semantic-Kernel only. So and then the control is given back to the organizer, and then organizer is actually pushing the contents to the get organizer. So if you see inside get organizer, so this is the actual coordinator which I explained earlier, which is from Semantic-Kernel. So I have defined the instruction for organizer. So what I'm stating is it is interacting with user and respond to the user queries, but if it is a specific task to be accomplished, then I am invoking the AutoGen plugin through kernel functions of Semantic-Kernel. So once the plugin generates the response, summarize that and share to the user is what I have mentioned here. And this is how we actually add the plugins to invoke the functions. So these are the default behaviors of Semantic-Kernel, which I explained in my Semantic-Kernel repository. So once user is giving a task, the control will be given to this invoke group chat. So inside it, so this is the code for Magentic One. So actually, if you see, it is a one-line code, like only 2 lines is required. So Magentic One implementation you have to put on the respective models you have to configure. And that's it. Like it will call the respective agents which is bundled inside Magentic One, and then it will perform the operation as required. So there is something called hill mode as true I have said. So this is nothing but in the explanation I have mentioned about user proxy agent, where whenever if the user intervention is required, if the system feels that user needs to input something, then user proxy agent will come into picture. So in Magentic One they have given a provision that if hill mode is set as true, then if at all any user input is required, it will invoke the user proxy agent, and then in the console itself it will be asking the user to give the clarification that system requests. So this is basically not required at this point of time, but for safety reasons I have put it here. And then I'm taking the results and then iterating it based on whatever the data that I need to extract and showcase to the console, to the chatbot actually. So this is what the actual code is for the Magentic One. The remaining parts are from Semantic-Kernel. So to configure the LLMs of your choice, you need to set these configurations in your environment. So you need to set the model, API key, API version endpoint, and the deployment name. So basically, I'm using Azure OpenAI, so I have given these configurations. So appropriately, you can make use of your own LLMs. Coming back to requirements, so these are the packages which I'm using during the development. So you may need to go for higher versions also. That is also okay. So Semantic-Kernel for the orchestration, Gradient for the UI, and Agentic AutoGen core extension and agent chat for Magentic One's capability. So since I have these packages already installed, straight away I'm going into the execution of the code. So this is the starting point of the execution. So if I run the bot interface, it will start the service with 8009 port as I mentioned here. So this gets started. So let's paste in the browser and see. This is the Gradeo chatbot, simple chatbot which I have created. So I'm going with just a greeting. So now the response is from Semantic-Kernel orchestrator. It is not going inside the AutoGen's Magentic One workflow. So now if I give, can you get me the list of folders in C drive? So now the expectation is like the Magentic One gets invoked because of there is a task given by the user, and then since the configuration, the setup is inside this system. It should able to explore the C drive and list out the folders which are present in C drive using the file explorer agent is what I feel. So similarly, it is actually doing the same thing. So here are the list of folders and then it is giving whatever the C drive contains. So now if we go and see inside the console, you can see some meaningful information which I want to showcase to you. So if you see, so this is the user input. So basically here if you see the plugin gets invoked because this is the action item which is given to the system. So the Semantic-Kernel orchestrator is actually giving the control to the Magentic One software through kernel function. So now the task is set, like get the details of list of folders in C drive. So the user input is captured and then Magentic One orchestrator is invoked. And it is actually framing set of steps to perform the operation. So basically if you see here, these are the 4 steps it is actually trying to do for any use case whenever it gets an input. So it will try to see the facts and it is looking up into the facts and then facts to derive and then the educated guesses. So whatever the request that you're giving, all these 4 steps will be followed strictly by Magentic One workflow. So here if we see before this, to answer this request, we need to assemble the following team. So it is actually forming a team with file surfer to explore the files and web surfer if at all it needs to access the internet and websites, coder if it needs to perform some operation, it will generate the code using coder agent, and computer terminal if at all it needs to invoke this generated code into a system, then it is requiring this computer terminal. Since I set the hell mode as true, which I showcased here, so it is actually introducing one more agent called user if human user. So which is nothing but a user proxy agent. Whenever there is a question from this team, then it will ask for the clarification to the user. So these are the agents involved. So these are the steps which is going to be followed. And if you see here, it is actually setting up a plan. So plan for addressing the request. So verify the local environment. Since the configuration is present inside my local PC, it is actually verifying the local environment and check permissions so that it can able to access C drive and retrieving the folder list and then reporting the results to the user if at all the step 3 is a success. So once it is formulating the plan, setting up the team and then having the strategies ready, what it does is Magentic One orchestrator is coming into picture and then it is asking please provide a list of folders in C drive. So now if you see, it doesn't require a web server to perform the operation. It may need coder just in case a file server is not able to execute it. If file server is not able to execute it, the generated code will be used by computer terminal to run it as a Python code or some other code to extract the details. So now the file server is coming into picture and then it is traversing across the C drive and then it is actually seeing the list of files and folders present. And then it is able to extract, so it is giving the control back to orchestrator stating that these are the list of files, so orchestrator is giving the response back to a user. So that's why we can see the list of files present in this C drive, right? Also if you see here, since the coder is not involved, there is no .py file or some other code got generated. I want to showcase one more use case in this. Say for example, I want to get the details of py to psi package from package from pypy.org site. So the expectation is now I want to extract the details of this package from this website. So my expectation is like it should use the web server to traverse and get the details. Let's see what's happening. There is a known issue in the system that file server is not working because of the configuration in my PC. There is a character encoding error which is actually happening. So if you see here search, so it is actually setting the same list of teams and plans. So if you see here, so this is the task. Get the details of Py2 package from this website, and it is actually assembling the team, formulating the steps, and then the plan. So it is assigning the web server. So no environment from file server code or computer terminal is necessary because it is the direct extraction from the website. But web server is having some encoding issue in my PC, so it is keep failing. So now if you see, it is trying to arrange another way to execute the same by formulating another plan. But even then it is going to web server, so it keeps going in that way, and then finally it got aborted. So we get a response like this, like it is not able to fetch it. So just to showcase to you that how the Magentic One framework works, I'm giving the same question now. Can you get the details of py2psi from pypy.org site without using web server? User may not know, but to showcase how the Magentic One workflow is actually going through, I'm just giving explicitly don't use web server because it is having some issue in my PC. So now my expectation is like it should skip the web server and then try to extract using the other agents which is present in the Magentic One team. Let's see the response. Okay, it is now getting some response. So if you see here, so the task explicitly constructed in this way without web server. So Magentic One orchestrator, it is actually assembling the team along with the web server, but given the set of activities and the plan, now it is telling that generate a Python script because explicitly the user is saying don't use web server. So the Magentic One orchestrator is actually stating generate a Python script that queries this website using this. So it is making use of the APIs present in PyPy website by generating a code. So code is used here to generate the code, and then running this script involves the computer terminal, as I said earlier. So this script will be executed by this agent. So generating script is done by coder agent, and then execution is happening through computer terminal. So once that is done, if you see, it is able to extract the details, right? And if you see it here, it is having the details, package name, py2psi, version, description, and other stuffs. Let's check this. Okay, so if you see here, a package to convert Python code to Python for security and obfuscation. So dependencies, it is having 3.0.2 or higher, version 0.0.1. Okay. Okay, fine. It is able to extract from the website. So this is how the Magentic One framework is actually performing the operation. And if you see, I want to refresh this to showcase. So if you see here, it is generating some files. So this .sh file, so web server is having some issue, right? So it will try to extract the code using the playwright package. So even though the web server is a failure now in this case, but it is trying to install all these dependencies on its own. So unless we see the logs properly, we may not know whether some other softwares are installed in our system or not. So that's why the documentation says that we need to execute this in the sandbox, because if the software is perfect one, we don't have any problem. If it is a vulnerable one, then our system might get infected. So that's why we need to use the sandbox. And if you see the .py code, so whatever the coder that generates the Python code to extract the details from py.org, if you see here, it is stored as a temporary file. And then this temporary file is actually taken by the computer terminal agent for its execution. So if at all any loggers present here, you could have seen that so only the print statement is there. So that's why we got this print statement in the output. So this is how the Magentic One's framework is defined. And if you see the documentation also, they have a technical report of whatever they have defined in the Magentic One benchmarks with respect to others. They have stated this as a paper. Maybe you can go through it. I have given the links for all these things in the repository itself. So whatever we have discussed so far, it is actually present in the AutoGen core library, and these agents, which are part of Magentic One as a bundle, is present as a standalone agents as well. So this is the architecture flow that the flow diagram that I have taken it from Microsoft, and there is one more. So this is the architecture actually. So how the orchestrator makes use of the agents which are present in the Magentic One flow is defined here. So you can check these documentations, papers, benchmark states, everything. I have given the links in my repository. That's it from my end for today. So go through it. Any questions or clarifications, drop comments. Thank you.